/13 October November 2023 exam. So our first question is about a curve in such that its gradient at xy is given by dy by dx. We have equation x equal x minus 3 over x square root. It is given the curve passes of 0.41. We have to find the equation of the curve at 41. So we have to integrate it. So y will be equal to x square by 2 minus 3x1 by 2 divided by 1 by 2 plus c. We will substitute the values of x and y. Y is 1, x is 4 plus c. So c will be equal to 5 and our equation will become y equal to over 2 minus 6 square root of x plus 5. This is our answer. For question number 2, we have equation of a circle that intersects the y-axis at a and b. So we will substitute the value of x equal to 0 because at y-axis x is 0. We will get the two values for y. So this will become y minus 4 whole square equal to 31. Square root of 31 plus minus plus 5. So the two coordinates are 0 under root 31 plus 5 and 0 minus under root 31 plus 5. For B part, find the equation of the circle which has AB as the diameter. So if AB is the diameter, first we have to find the coordinates of the center and the distance of the radius. We have coordinates as 0, 5. Because if AB is the diameter and the circle passes through 0, 5. So because the midpoint will be the radius. This is A, this is B. If it's a diameter, so midpoint will be the coordinates of the radius. So its midpoint will be equal to 0 plus 0 over 2 and 5 plus under root 31 plus 5 minus under root 31 over 2. Cancel these two. So answer will be 0 and 5. For the length of radius, we will find the magnitude of AB whole square. So it would be, wait, there's a difference in the signs. We have a minus sign here, a negative sign here. So this will become minus 2 under root 31 whole square square root. So this will be 4 into 31 square root 12. So that will be our value for radius. So we will apply it in the equation of circle. So this will become x minus y, x minus 0 whole square minus y minus 5 plus y minus 5 whole square equal to. So we have to find the radius. So this will be 2 under root 31. That is a diameter. Radius will be 2 under root 31 divided by 2. That would be under root 31. So we'll write under root 31 square here. And this will be the final equation. So we can erase this part. Right? So now we will move on to the next question. Question number 3, we have a trigonometric equation 5 cos theta minus sin theta tan theta. This will become 5 cos theta into sin theta over cos theta plus 1 equal to 0. We will take the LCM. This will become 5 cos square theta minus sin square theta plus cos theta equal to 0. We will substitute the value of sin square theta as 1 minus cos square theta equal to 0. So this will become 5 cos square. This will become 6 cos square theta minus 1 plus cos theta equals to 0. We will rearrange it to get this equation. We will have a equal to 6, b equal to 1, and c equal to minus 1. For part b, we will now factorize it. We have the simplified form equals to 6 cos square theta plus cos theta minus 1 equal to 0. The two factors will be 3 cos theta minus 2 cos theta minus 1 equals to 0. We will take 3 cos theta common. This will become 2 cos theta plus 1 minus 1 into 2 cos theta plus 1 equals to 0. So the two equations will become 2 cos theta plus 1 equal to 0, 3 cos theta minus 1 equal to 0. So cos theta will be equal to minus 1 by 2 and cos theta equal to 1 by 3. Theta will be equal to 1.23 radians and 2.09 radians. And in the second part, theta will be 5.05 radians and 4.19 radians. These are the two answers. For question number 4, we have to expand it for the power of x square. We will use 5c0, 1 power 5 to x power 0, plus 5c1, 1 power 4 to x power 1, 5c2, 1 power 3 to x whole square. So this will be 1, 1, 1, 5, 1, 2x, and 1, 4x square. This will become 1 plus 2x plus 40x square. For part B, this will become 6c0, 1 power 6 minus ax power 0, 1 power 5 minus ax power 1, c2, 1 power 4 minus ax power 2, 1, 1, 1, 6c2 is 15, minus 6ax x square. Okay, for part B, the expansion of these two, the coefficient of x square is minus 5. So we will write the expanded version here. (15x square). This will be simplified to 1 into 15 a square x square minus 6ax 40x square into 1 equals to minus 15x square in a square x square minus 60 ax square plus 40x square equal to minus 5x square. We will eliminate x square now. The simplified form will become like this, 45. So 15a square minus 60a plus 45 will be equal to 0. We will have to make the factors. So it will be 15a square minus 15a minus 45a. 45 equals to 0. So the two factors will be a minus 1, a minus 3 equal to 0. So a equal to 1 and a equal to 3 are the two answers. So question number 5, part A, we have these geometric sequence. So in this, R1 will be equal to 5p over 2p plus 6, and R2 will be equal to 8p plus 2 over 5p. R1 is equal to R2 if it's a geometric progression. So 5p over 2p plus 6 equals to 8p plus 2 over 5p. We will cross multiply to get 25x square, 2p plus 6 into 8p plus 2. This will be 9p square minus 52p minus 12 equal to 0. By factorization, we will get p equal to 6 and p equal to minus 2 by 9. These will be the two answers of p. For part B, we have one of the values of p found in is negative fraction. So yes, we have p equal to minus 2 by 9. We have to use it to find the sum of infinity. So if p is minus 2 by 9, a1 will be 2 into minus 2 by 9 plus 6. This will be equal to 50 by 9. So s infinity is equal to a1 over 1 minus r. 5 into minus 2 by 9 divided by 2 into minus 2 by 9 plus 6. So this will become minus 1 by 5. This is the value of r. So for s infinity, we will use these two values. We have a1, 50 by 9 over 1 minus r. So 50 by 9 over 1 plus 1 by 5 is equal to 125 over 27. So this is our answer. Now we will move on to question number 6. We have equation of the line 6x minus c, and equation of curve as c x square plus 2x minus 3. The line is tangent to the curve at P. Find the possible values of c. If it is tangent, so these two equations should be equal. So 6x minus c is equal to c x square plus 2x minus 3. We will rearrange it to get c square minus 4x minus 3 plus c equals to 0. We will apply discriminant here. So minus 4 square minus 4 into c into equals to 0. We will simplify to get 4c square minus 12c minus 16 equal to 0. The two values for c will be 4 and minus 1. These are the two values for c. So we have to find the values. Now we have to find the corresponding values of p. So if c is 4, so equation will become 4x square minus 4x plus 1 equals to 0. And if it is minus 4, so it will become minus 4x square minus 4x minus 4 equals to 0. So now we will simplify these two. We will apply factorization. 2x plus 1 equal to 0. So the value of x will be 1 by 2. We will substitute x equal to 1 by 2 to find the value equation of y. So y will be equal to minus 1. 1 by 2 and minus 1. These are the first part, and for second one, vectors will be, this will be simplified to x plus 2 whole square equals to 0, minus 2. Y will be 6 into minus 2 plus 1, minus 11. And the two factors are minus 2 and minus 11. These are the values of x and y. Now we will move on to question number 7. We have to find the range. We have a fraction and constant value of 1. So this means range is greater than 1 because we have a positive sign here. Obtain a fraction for f inverse. So we will substitute, let y equal to fx, x equal to f inverse y. So y will be equal to 1 plus 3 over x minus 2, y minus 1 equal to 3 over x minus 2, y minus 1 equal to x minus 2 over 3. So this will be 3 over y minus 1 equal to x minus 2, and x equal to 3 over y minus 1 plus 2. F inverse of y equal to 3 over y minus 1 plus 2, and f inverse of x will become 3 over x minus 1 plus 2. This will be our answer, and we have to find the domain. So domain of a main function is equal to range of the inverse function. So a range of a inverse function will be equal to domain of the main function. So in this case, we have range of main function as fx is greater than 1. So domain of inverse function would be x is greater than 1. Or you can further simplify to get 2x plus 1 over x minus 1. This will be your second answer, right? Now move on to part C. We have gx equal to 2x minus 2. We have to find g of fx. So we have to replace the x of g in gx with the value of fx. So it will become g into 1 plus 3 over x minus 2. This will be equal to 2 into 1 minus 3 over x minus 2 minus 2. This will be equal to minus 3 plus x plus 1 x minus 2. So this will become 6 over x minus 2. That is our answer. Now look at question number 8. We have a graph of a trigonometric function. The diagram shows part of the graph y equal to sine a x plus b, where a and b are positive constant. We have to find the values of a and b. Okay, b represent horizontal movement. So the graph of sine x should intersect at 0, but it moves to the left. So this means b should be pi by 3. A negative pi by 3 means it will move towards right, and positive pi by 3 means it will move towards left. So b should be positive pi by 3, and the graph repeats its values within interval of 2 pi. So the graph should be like this if it's a graph of a sine x, but it has covered only one loop till 2 pi, because 5 pi by 3 represents a horizontal movement of minus pi by 3 as well. So we will consider it from minus pi by 3 till 5 pi by 3 at interval of 2 pi. So we will say it has only covered half of the part. So the value of a will be 1 by 2, because in a period, if the period extends, the value multiplied will be in fraction in 1 over form, and if it shrinks, then it will double. Suppose if it intersects the graph like this till 0 to 2 pi, so the period will become a equal to 2. It shrinks, right? So whenever it shrinks, it will multiply with the variable, and whenever it expands, it will divide. For question number 8, part B, we have to find the coordinates of the stationary point from the transformed curve in terms of P and Q. So the x component of transformed curve is 1 by 4 x plus 8. We will write it equal to P, and the y coordinate will be equal to minus 3q, because we have stretch factor of minus 3 at the beginning. So y will be minus 3q, and x will be 4p minus 8. So these will be the two stationary points of the transformed curve. Now we will move on to question number 9. We have equation of the curve y equal to 2 square root x minus 1. We have to find the equation of the normal at the point 4, 3. For that, we have to take the derivative. So dy by dx will be equal to 2 into 1 by 2, x power 1 by 2 minus 1 minus 0. Cancel these two to get 1 over square root of x. Value of x is 4, so m1 will be equal to 1 over square root of 4. That would be 1 by 2, and m2 will become minus 2, because it is a gradient of the normal. We will use the equation m1 m2 equal to minus 1. Substitute 1 by 2 here to get m2 equals to minus 2. So equation of normal will be y equals to minus 2x plus c. We will substitute the coordinates 4 and 3. Get the value of c, which is 11. So the final answer will be minus 2x plus 11. Now for the b part, we have a point is moving along the curve y equal to 2 square root x minus 1 in such a way that at a the rate of increase of the x coordinate is 3. So we have dx over dt equals to 3. We have the equation of the curve y equal to 2 square root x minus 1. So dy by dx should be equal to, we will apply a chain rule. This will be equal to dy by dt into dt over dx. We have to find dy by dt. So from the first part, we know the derivative of y. So we will have 1 over square root of x equal to dy by dt into 1 by 3, because we have dt over dx here and dx over dt is 3. So dt over dx should be 1 by 3. We will substitute the value x equals to 4 from the last part. So we have dy by dt here into 1 by 3. Cross multiply to get 3 by 2. And that would be our answer.
Now, for the C part, we have at A, the moving point suddenly changes direction and the speed moves down the normal in such a way that the rate of decrease of y coordinate. So dy by dt is equal to minus 5 centimeter per second. We have to find dx over dt. And now we need the gradient of the normal because it's moved down the normal. So we will use dy by dx equal to dy by dt into dt over dx. But for the gradient dy by dx, we will use the gradient of the normal, which we have found in the previous part equals to minus 2. So we will use minus 2 here, minus 5 here, and dt divided by dx. Cancel these two to get 2 by 5 equals to dt over dx. So dx over dt will be equal to 5 by 2, and that is our answer. Now we will move on to the next question.
Number and 10. We have been given with a diagram which has point A, B, C lies on a circle with center O and radius R. We have an angle A O B equal to 2.8. The shaded region is bound by two arcs. The upper arc is part of the circle with center O and radius R. The lower arc is part of the circle with center C and radius capital R. We have to find the size of angle ACO in radians. So ACO will be equal to 2 pi minus, sorry, AOC will be equal to 2 pi minus 2.8 over 2, that is equal to 1.742, and angle ACO will be equal to pi minus 1.742 over 2, that is equal to 0.7 radians. For B part, we have to find R in terms of R. So R square will be equal to R square plus R square. That would be 2 into R, sorry, minus 2 into R cos 1.742. So capital R is equal to 1.53 R. For C part, we have to find the area of shaded region. That would be 1 by 2 R square theta, 1.5 R square. A2, A1 is angle OAB. So A2 for angle OAB will be equal to 1 by 2 into R square into 2.8 R square, 1.4 R square. Wait, we have to use capital R square here. 2 into 0.7. So this will become 0.7 R square. So we will substitute the value of 1.53 here. This will become 1.638 small r square. And now we have to find the area of triangle. That would be 2 into 1 by 2 into small r into capital R sine 0.7. This will be equal to 0.985 small r square. So required area will be equal to 0.747 r square. For question number 11, we have y equals to x plus 2 over 2x minus 1. Now we have to find the x coordinate of capital R, which verified x coordinate of capital R is 3 by 2, and y coordinate, we have to find y coordinate of R. The lines intersect at x equal to 1. Lines intersect with the curve at x equal to 1 and x equal to 2. So first we have to find the derivative of the curve. So that will be dy by dx equals to 1 plus 2 into 2x minus 1 power minus 3 into 2. So this will be equal to 0. So this will become 1 plus 4 over 2x minus 1 whole cube minus 1 cube is equal to 2. Okay, we have another minus 2 here as well. So this will become 1 minus 8 over 2x minus 1. So 2x minus 1 will be equal to 2. 2x will be equal to 3, and x is equal to 3 by 2. So if x is equal to 3 by 2, y will be equal to 3 by 2 plus 2 over into 3 by 2 minus 1 whole square. So y is equal to 3 by 2 plus 1 by 2. Y will be equal to 2. So the two coordinates are 3 by 2 and 2. This will be our answer. Now we have to find the exact area of the shaded region. For this, we have to find area of the trapezium and area under the curve. So y will be equal to 2 plus 2 over 2 into 2 minus 1 whole square. Y is equal to 20 by 9. So we have to find the value of y here and then here. And when x is 1, y will be equal to 2 over 2 into 1 minus 1 whole square. So y will be 3. So the two coordinates of q and p are 2 and 20 by 9. And for p it is 1 and 3. Now we have to find area under the curve. That would be 2 to 1. X plus 2 into 2x minus 1 power minus 2. So this will be x square by 2 minus 1 over 2x minus 1, 2 to 1. We will substitute the values here. Minus 1 over 2 into 2 minus 1. 1 over 2 minus 2 into 1 minus 1. This will be equal to 5 over 3 plus 1 over 2, 13 over 6. This is 1. Now area of trapezium will be the whole shape EQ12. The whole shape is trapezium. So that would be 1 by 2 into 1 into sum of parallel sides. That's why we have found the value of y. That would be equal to 47 over 18. So our required area will be equal to 47 over 18 minus 13 over 6. So that would be equal to 4 over 9. So that is our answer, and that's the whole paper.